Before we begin, if you enjoy simple technology explanations that make complex topics easy to understand, make sure to subscribe to Zenith Tech, like this video, and turn on notifications so you never miss our next upload. Every day, billions of messages, passwords, credit card numbers, and personal files travel across the internet. But have you ever wondered how this sensitive information stays private while passing through networks that anyone could potentially access? The answer is encryption. It's one of the most important technologies in modern cybersecurity, protecting everything from online banking and messaging apps to cloud storage and online shopping. In this video, you'll discover what encryption is, how it works, and why it's essential for keeping your digital life secure. Imagine writing a secret letter to a friend. If you send it in plain English, anyone who intercepts it can read every word. But what if you transformed every letter into a secret code that only your friend understood? Even if someone stole the letter, it would appear as meaningless symbols. That's exactly what encryption does with digital information. It converts readable data, called plaintext, into an unreadable format known as ciphertext using a mathematical algorithm and a secret key. Without the correct key, the encrypted data is practically impossible to understand. Whenever you log into a website, send a text message, make an online payment, or upload files to the cloud, encryption is working behind the scenes. Instead of sending your information in plain text across the internet, your device encrypts it before transmission. The encrypted data travels safely across networks, and only the intended recipient can decrypt it back into its original form using the correct key. Even if hackers intercept the data during transmission, all they see is a collection of random characters with no useful meaning. Encryption relies on mathematical algorithms rather than simply replacing letters with different ones. Modern algorithms perform thousands or even millions of complex calculations to scramble the data. These calculations are designed so that reversing the process without the correct key would require an enormous amount of computing power. For strong encryption standards, attempting every possible key could take far longer than the age of the universe using today's computers. There are two main types of encryption used around the world. The first is called symmetric encryption. In this method, the same secret key is used to encrypt and decrypt the data. Think of it like a locked box that uses one key for both locking and unlocking. As long as both people have the same key, they can securely exchange information. Symmetric encryption is extremely fast, making it ideal for encrypting large amounts of data such as files, hard drives, and cloud storage. The second type is called asymmetric encryption, also known as public key encryption. Instead of using one key, it uses two mathematically related keys. One is a public key that anyone can know, while the other is a private key that only the owner possesses. If someone encrypts data using your public key, only your private key can decrypt it. This makes it possible to communicate securely with people you've never met before without first sharing a secret key. You might wonder why both systems exist. The answer is that they each have different strengths. Symmetric encryption is much faster and more efficient, while asymmetric encryption provides a secure way to exchange keys and verify identities. Modern internet security combines both methods to achieve speed and security at the same time. A perfect example is when you visit a secure website using HTTPS. Before any sensitive information is exchanged, your browser and the website perform a secure handshake. During this process, asymmetric encryption is used to verify identities and safely exchange a temporary symmetric key. Once both sides have that shared key, they switch to symmetric encryption because it's much faster for transferring large amounts of data. This entire process happens in just a fraction of a second, and most users never notice it. Encryption protects far more than websites. Messaging apps use end-to-end encryption so that only you and the person you're chatting with can read the messages. Cloud storage providers encrypt files before storing them on their servers. Smartphones encrypt your photos, contacts, and documents to prevent unauthorized access if the device is lost or stolen. Businesses use encryption to protect customer information, financial records, and confidential company data from cybercriminals. One important thing to understand is that encryption doesn't stop hackers from stealing encrypted files. Instead, it ensures that stolen data remains useless without the correct decryption key. That's why protecting encryption keys is just as important as protecting the data itself. If an attacker obtains the key, they can unlock the information just like the rightful owner. As technology advances, encryption continues to evolve. Cybersecurity experts constantly develop stronger algorithms to stay ahead of increasingly powerful computers. Researchers are even preparing for the future impact of quantum computers, which may eventually require entirely new forms of encryption designed to resist their incredible processing power. Today, encryption is one of the foundations of the modern internet. Without it, online banking would be unsafe, e-commerce would be nearly impossible, private messaging wouldn't exist, and digital privacy would disappear. Every secure website you visit, every online purchase you make, and every protected account you access depends on encryption working silently in the background. The next time you see the small padlock icon in your web browser, remember that powerful mathematical algorithms are protecting your information every second. Encryption isn't just another cybersecurity feature, it's one of the reasons we can safely communicate, work, shop, and live in a connected digital world. If you enjoyed learning how encryption works, don't forget to like this video, subscribe to Zenith Tech, and share it with someone who wants to understand the technology behind the internet. We have many more beginner-friendly videos explaining artificial intelligence, cybersecurity, networking, computers, and the digital world, so stay tuned for the next one.